Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsiri Sopongwane, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Cybono Discovery Center. Remember, grade 12, our WhatsApp number is 079 578 2908. You are more than welcome to send the clarity seeking question to that particular number. I am repeating is 079 578 2908. And then today we'll be looking at paper 1, November exam readiness. As of we are writing tomorrow, grade 12s. And then now there's the stationery that is needed, and all your stationery must be inside the transparent plastic pocket, not your pencil case, grade 12, on a transparent plastic pocket. Remember your ID book, your exam timetable, of which is your admission letter to the exam room. Remember your calculator check, it must be with a new battery. If not, please have a new battery on standby. You must have a blue pen with an extra pen in case you have a challenge with your pen. And then you must bring in your pencil, your eraser, and the ruler, grade 12. Please ensure you have all the necessary stationery. And then around the exam tips, you must arrive an hour before the starting of an exam. That is very important, grade 12, so that you can relax enough before the starting of the session. And then do not try to cram, do last minute revision or discuss the exam while waiting to go into the exam room. That is very important because you need to relax before you get into that examination room. This may just make you more nervous and confused. So you avoid cramming and discussion around the content that you have revised. Do not panic. You have prepared well. Use a calculator that you have been using when you were practicing. Do not use a certain type of calculator practicing and then now when you go to an exam room, you take a new calculator that you don't even know how does it operate, grade 12. Use the same calculator type that you've been using when you were practicing. Do not use a correction fluid like your T-Pex. Rather, scratch out a wrong answer lightly with a pencil or pen and rewrite the correct answer. Grade 12, do not use a correctional fluid, please. If you answer a question twice, only the first attempt will be marked, even if the second solution is correct, grade 12. You need to give us only one final solution. If now you have written 2, please ensure you cancel the one that is wrong and only remain with the correct answer. Because if you leave both of them, we are going to mark only the first attempt. We'll assume that your answer is the first attempt. We will ignore the second one. Even if the second one is the correct one, we won't consider that, grade 12. And then delete the incorrect solution. Do not expect the marker to decide for you. I've already elaborated on that one. What to do when you receive your question paper now? You will be given a 10 minutes reading time. During this time, go through the entire paper. And then as you're going through, also plan how will you answer the questions. Identify the questions where you are more likely to collect more marks. We are advising you, grade 12, to always start with your question 1, 2, and 3, because that is the easiest questions on your question paper. Please ensure you have answered all 3 questions before you can continue to other questions. And then read the instructions and ensure that you round off all the questions to the right number of decimal places. Only at the final answer, you will be penalized for incorrect rounding off, grade 12. Remember, on your instruction sheet, it will be indicated that round off your answers to 2 decimal places unless stated otherwise. Grade 12, that means throughout your paper, you are allowed to round off to 2 decimal unless there's a message next to the question that needs a specific rounding off. And then check whether there are special diagram sheets provided at the back of your question paper. especially for your graphs in paper 1. Use all the 3 hours given right in the paper and checking your work. Use your 3 hours, grade 12. Try to spend at least 1 minute per question. Roughly, it's 1.2 grade 12 at maximum. You can't spend more than that because now you won't be able to finish your paper. All right. And then when we are looking at paper 1, these are the questions that falls under paper 1. We are having your algebra, and then with algebra, this is weighting 50 plus minus 3 out of 150 marks of paper 1. 50 marks will be all your algebra grade 12. And then with functions and graphs, that is the second topic, that is worth 35 plus minus 3. And then finance, growth, and decay, it was 15 plus minus 3 marks. And then differential calculus and integration, 50 marks plus minus 3. As you can see, grade 12, the algebra, differential calculus, and integration, those are the topics that are dominating in terms of the high number of marks there. Right, at the back of your question paper, you will be having an information sheet with all the formulas for both paper 1 and 2. And then the part that is starting on the information sheet, it is composed of your paper 1 formulae grade 12. And then I have classified your formulas just to remind you that the first 2 rows there, columns, they are for algebra, functions, and graphs. And then followed by, the minute you have A equal to P, you must know you are busy now with finance, growth, and decay formulas up to the effective rate there. And then now followed by the differential calculus. Differential calculus, we are relying on the first principle formula. And then integration, this one is playing a major role, grade 12, because now it is telling you exactly how to integrate. That means this part here is giving you answers already to your integration part. So this integration formulae, they play an important role in terms of answering integration. Right, and then now under algebra, remember we said algebra is 50 plus minus 3. We are having quadratic equations, quadratic formulae, quadratic inequalities there. And then when we talk to quadratic equation, we are referring to the original equation, ax squared plus bx plus c equals to 0. That means before you can start solving any quadratic equation, you need to write your equation in a standard form, of which is ax squared plus bx plus c equals to 0. If there is something equal to a certain number on the right hand side, you transpose everything to the left hand side and rearrange in the order starting with x squared followed by x and the constant number then. And then now we are having a quadratic formula. And then this is the quadratic formula, grade 12, x equal to minus b plus minus the square root of b squared minus 4ac over 2a. And then we use this to solve quadratic equation with or without factors. But without factors, you are forced to use this particular formula. With factors, in some cases, you can use the short method of factorization if you are comfortable with that. But grade 12, if you have a challenge, you are more than welcome to use this quadratic formula. And then in some cases now, you'll end up with the square root inside the square root sign there, ending up with a negative number. In that case, that means you'll be bringing in what? Complex numbers in case where your roots are non-real or are they imaginary. And then what do we mean about that? I've already elaborated on it. It's where you are having the square root of a negative number. And then with quadratic inequalities, yes, we are applying the same factorization method as in equation to find our critical values, but the values of x are not yet the solution. They are just what? The critical values, grade 12, not yet the solution, because now we have solved this using the equation method, whereas we are solving an inequality. So now remember, now in inequality, the minute you multiply or divide by a negative, you are reversing the inequality sign. The minute you multiply throughout by a negative or you divide throughout by a negative, you are affecting your inequality. If it is less than, it will now become a greater than. If it is greater than, it will now become less than. And then remember, now you need to represent your solution graphically before you go for a conclusion or concluding your final solution. No diagram, no final solution in inequalities. Right, let's look at the quadratic equations now. Here we have the first activity. If we look at this activity, you are given two brackets on the left hand side equal to a 0 on the right hand side. If that is the case, grade 12, that means if there's a 0 on the right hand side and the bracket on the left hand side, they have already factorized for you. There's no need to factorize. This is already in a factor form. How do we know? There are brackets equals to a 0. So you can go straight and say 3x plus 6 is equal to 0 from the first bracket, or the x minus 5 equals to 0, which you'll end up with 3x transpose the 6 to the right hand side becomes minus 6. Divide both sides by 3. Therefore, x is equal to a minus 2, or transpose minus 5 to the right hand side, x will be equals to 5. Therefore, these are the solutions for that particular equation. It is worth 2 marks. That means it will be only for the final solution, 1 each, of which is total to 2 marks. Okay, the next question, we are still on quadratic equations. We are given that x squared minus x minus 12 is equals to a p. Can you see now it is not equal to 0 but equals to a p. Now solve for x if we are given the following conditions. At 2.1 we are given that if p is equals to a 2, that means they are saying to you remove this p here and substitute with a 0. So you end up with x squared minus x minus 12, and then substitute a p with the 0. Can you see now it's a quadratic equation in a standard form equals to a 0. And then grade 12, it's up to you. If you use a quadratic formula, it's fine. Or if you are comfortable with factorization, you can also apply that. So if we look at this, we are looking at factors of 12. So when you talk factors of 12, we say 1, we have 2, we have 3, we have 4, we have 6, and a 12 itself. So now when you look at the product of that, it will be 1 times 12, 2 times 6, and 3 times 4. These are all possible vectors. Can you see that? 1 times 12, 2 times 6, and 3 times 4. So after identifying the product, now we go to our quadratic equation. It says factors of 12. When you subtract them, they must give you a minus 1. Okay, 12 minus 1 is 11, 6 minus 2 is a 4, 4 minus 3 is a 1. Therefore, these are the factors that we are looking for. And then in order to get a minus 1, that means 4 must be negative, Rachel. So happy now, we have analyzed everything. We can now bring in the factors. It's x plus 3 and the x minus 4 equals to a 0. So the first bracket, we end up with x equals to minus 3, or the x equals to n equals 4 then, positive 4. Now, if we decide to use a quadratic formula now, let's see now. You will end up with x equal to minus, it must be minus b, our b is minus 1 here, then it will be minus 1 plus minus the square root of b is minus 1 squared minus 4ac, everything over 2a, and then our a is 1, and then our c is minus 12 there, and then 2a is 1 there. So now if you put this into your calculator, grade 12, it will still give you x equal to minus 3 or an x of which is equals to 4. So it's up to you, grade 12, which method is more easier for you. And then now let's look at number 2. We are still using the same equation. And then they say now this p is now less than 0. So remember now P is represented by this equation because they are equal. So if they say P is less than 0, we are going to remove a P and put what? An x squared minus x minus 12 because they are equal. So this will be less and equal to 0. Can you see grade 12? We have created an inequality now. Okay. Now there's no need to look for critical values. We have already calculated that on the previous question because this is the same quadratic equation. Remember, we ended up with the x. This will be criticized because we are talking inequality now. We ended up with x equals to minus 3 or x equals to 4 on the previous question. No need to start factorizing and so forth because we have already done that grade 12 in 2.1. So from here we can go to our number line, a table, a parabola function, any method that you are using at school grade 12. You can apply the method as long as you understand it. And then we start by indicating the smaller number minus 4 followed by the positive 4. And then now if we look at our inequality sign, it is having less and equals to. That means it will be a shaded dot because the values are included. 4 and minus 3, they are part of our solution. And then if it is less than, we are shading in. Therefore, x will be in between because our solution is between these two numbers. Between what? Minus 3 and a 4. That is the solution for that. And it says 1 mark, that means it's 1 mark for the final solution. It can worth 1 or 2 marks, it depends on the examiner. And then 2.3, we are still on the same equation now. And then it says now when P is equal to minus 5, correct to 2 decimal places. Let's substitute P for the place of P there. This will be equal to a minus 5. Transpose, remember there must be a 0 on the right hand side. And then if we take minus 5 to this side, it will be plus 5. Minus 5 to the right hand side, to the left hand side is plus 5. Minus 12 plus 5 is what, grade 12? It's a minus 7 equals to a 0. Factors of 7 is only 1 and 7. There's no way you can have factors of 7. When you subtract them, you get a 1. That means we do not have factors for this. And then this is also confirming to us. This message here, the minute you have that message, it is indicating to you that you do not have factors for whatever trinomial you'll be solving there. So you need to use what? You are forced to use a quadratic formula. So now remember the value here is the value of A, the coefficient of X is the value of B, the constant number is the value of C there. So we are having X is equal to minus B plus minus B squared minus 4AC, everything over 2A. And then now let's substitute is negative from the formula. And then B from the equation is another minus 1 plus minus the square root of negative 1 squared minus 4. And then A is positive 1 and C is minus 7. Everything into the square root sign. Division from this point, grade 12 throughout there. And then is 2 into A. A is equals to 1. And then you put that into your calculator, grade 12, straight to the answer. But before that, you give us the simple set form of this. It will be x equal to 1 plus minus the square root of 29 over 2. And then now you can change this to decimal. Remember, you are rounding off to 2 decimal places. Please ensure you round correctly. So that is 3,19 or the minus 2,19. Those are the possible x values now. So the first mark will go for the correct quadratic equation, second one for substitution into the correct formula, the third one for the first x value, the fourth one, the second x value, correctly rounded off to 2 decimal places. Therefore, this is worth 4 marks. And then now we are having the simultaneous equations. We have some few notes there. Now, when you are solving simultaneous, it says simultaneously because you will be solving two unknowns at the same time. The minute you solve two unknowns at the same time, you must be given two equations. Rachel, there's no way you can solve simultaneous without having two equations, because look at this, you are solving for x and y simultaneously. So what is the method now? You make one variable from the linear equation subject of the formula. This is the linear equation. And then from there, you substitute into the quadratic equation. That equation that you have created there, you will be substituting into the quadratic. The quadratic is the one that is having exponent 2. And then remember that you are solving for two unknowns, x and y, both of them. And then now substitute the solved value into the linear equation to solve for another unknown, right? Let's follow the procedure now. Make one variable from linear subject of the formula. So now we are targeting x because the coefficient is 1 there. So we will leave x to this side and then transpose 2y to that side. It will be 3 minus 2y. Then this will be our third equation. And then after creating that, we are going to substitute this equation into the quadratic one. That means wherever we see an x now, we are going to substitute with 3 minus 2y. X will be substituted. Can you see grade 12? I am highlighting that x that will be substituted. And then we'll be having 3. And then we have 3 minus 2y. And then this will be squared plus, and I'm bringing in y next to 4 here. It will be 4y. And then now I'm substituting my x. That is very important, grade 12, because most of the time you forgot to multiply that y in. So take the y to the front, and the one that you need to substitute, just swap the position. It will not affect you as long as you don't put a plus or minus in between. So now for the x value, we are substituting 3 minus 2y plus the 2y squared, and then we transpose a 9 to the side, it will be minus 9, so that we can have a 0 on the right hand side. And then the next step, we are now removing the bracket, and then we leave 3 because we will be busy inside this bracket here. 3 minus 2y squared, you square the first term, 3 squared is 9, multiply the first by the second, minus 6y, multiply by 2, minus 12y. Square the last term, minus 2y squared is plus 4y squared. It's up to you, grade 12. You can even do your two brackets. You'll end up with the same answer. Okay, multiply them on the side, and then you can just bring it into your problem here. And then you're going to distribute this 4y into the bracket. That is 4y times 3, that is for 8, 12y. And then 4y times negative 2, that is minus 8y squared, grade 12. We have 2 y's there, it is y squared plus 2y squared, bring down 2y squared, and minus 9 equals to a 0. Remember, we still have a bracket that we need to deal with there. We are going to multiply 3 in down, 9, 18, 21, minus 3 times 12, that is 36y, plus 4 times 12, for 8, 12, 4 times 3 is for 8, 12, y squared plus 12y minus 8y squared plus 2y squared minus 9 equal to 0. And then from here, grade 12, we are now going to add the like terms. Let's add the like terms now. We are having 9, 18, 27 here. That is 27, yes. And then you, as you are adding, you also arrange in order. You're going to start with the y squared, followed by y and the constant number. Now, let's look at the y squared. This is the y squared, another y squared there, and another y squared there. So we have 12y squared minus the 8y squared, then we'll be left with 4y squared plus 2y squared, of which is 6y squared there. Right, then we are done with the y squares. We now target the y because we need to arrange in the correct quadratic form. So it's minus 36y plus 12y. How much, grade 12? Minus 24y. And then lastly, we now come with the constant numbers. We are having 27 minus 9 there. 27 minus 9, how much do we have? We have 18 plus 18 equals to a 0. We now have a quadratic equation, grade 12. Now, remember, we are solving for two unknowns. So now here we will be solving for y as if we are solving a quadratic equation. We can divide through, this is 24, we can divide through by 6, and then 6y squared divided by 6, that is y squared. 24 divided by 6, that is 4y. 18 divided by 6, that is 3, equals to 0. So we are looking for factors of 3. When you add them, they give you a minus 4. That means it's the y minus 1 and the y minus 3. Can you see, grade 12? Now you end up with what? With y equals to 1 or y equals to a positive 3. Remember, we are solving for two unknowns. Up to this case, we have only the values of y. We must also calculate the value of x. We advise you to take this equation at that step and substitute the value of y to get x. X will be 3 minus 2y is 1. And then now 3 minus 2 is a 1. That will be your first x value. The second one will be 3 minus 2. We are substituting a 3 now. That will be 3 minus 6. That will give us a minus 3. So basically, grade 12, these are the solutions for that. In coordinate form, it's 1 coordinating with 1 x value with 1 y value. And then the next one, the x is minus 3 coordinating with y equal to 3 there. And then these values, when you are comparing two equations, it's where you are having the point of intersection. It's where the two are equal, so you solve them simultaneously. You can have the same type of question on your equations. Okay, we are still on equations. We now move to literal equations, grade 12. With literal equations, where will we have variables on our equations now? Remember, on the previous, we are solving for x and y. But when you talk literal, it can bring in your trade equation, your technical math, formulas, and so forth. So now we are integrating this with technical mathematics. So it relates to real-life technical problems, and then mostly technical trade subjects and your technical sciences, right? In this case, now we are given acceleration is the change in velocity over change in time and is represented by the equation. This is the equation that is given to you. And then where a is an acceleration in meters square seconds, and then v1 is initial velocity measured in meters per second. v2 is the final velocity measured in meters per second. And then t is the time measured in seconds. Okay, v1 initial, v2 is the final one. Right, and then the question says that make v1 the subject of the formula. Right, remember you are given a is equal to v2 minus v1, final velocity minus initial velocity over time. So what is our target now? We must make this v1 subject of the formula there. And then how do we do that, grade 12? You start by removing this t now on the denominator now because it's blocking everything. So how do we remove that? We are going to cross multiply this to a. Then we'll be having at on the left hand side and then v2 minus v1 on the right hand side. So we want v1, not minus v1. So we are going to take this minus V1, transpose it to the left, and then take AT, transpose it to the right. They are shifting now. Okay, minus V1 to the left, it becomes positive V1. Equals to, remember V2 is still on the right hand side. We are only taking AT to the right hand side. It is positive. It will now become minus AT. So that is the correct formula for V1, of which is V1 equal to V2 minus the AT. We have managed grade 12 to make V1 subject of the formula. Now this is allocated 2 marks. 1 mark will be for cross multiplying, and the last mark is for making V1 subject of the formula. Hence, this is worth 2 marks. Remember, grade 12, you are more than welcome to send your clarity seeking question to our WhatsApp number 079 578 2908, grade 12. Also, your alternative solutions that you like to share with the rest of us, you can also send to that particular number. Right, we are still using the same information, same formula as the previous one. Okay, and then now they say a sprinter increases his speed from X meters per second to 15 meters in 2 seconds. From this X meters per second to 15, that is the speed. Okay, and then the acceleration of the sprinter acceleration is 2,5 meters per second. Determine the sprinter's speed at the beginning of the sprint in meters per second. So when we are talking the speed, grade 12, it is relating also to velocity. Right, now we are still going to use that formula or the one that we have calculated previously. The question says, okay, let's repeat reading and analyzing the question. A sprinter increases his speed from X meters per second. If it says from, that means the speed initially, it was X meters per second. We don't know the initial speed of the sprinter, but it ended up with the speed of 15 meters per second. In how many? In 2 seconds. The speed increased to that in 2 seconds with an acceleration of how much? 2,5 meters per second squared. This is supposed to be second squared, colleagues. Grade 12. And then now from here, the question says determine the sprinter at the beginning. That means we are looking for this value here. Can you see we are calculating V1? Yes, you can use the previous formula V1, or you can still use that one. Okay, V1 is equal to V2 minus AT, as we have simplified above on the previous question. And then now we can substitute the value. V2 is 15 meters per second minus the acceleration of 2,5 meters per second squared. And then now T is 2 seconds. We will consider the units at the end of the final answer. Okay, so now when you put this into your calculator, grade 12, you end up with 10. And then since this is a velocity or the speed, the unit will be meters per second. And then now this is 2 marks. 1 mark will be for substitution correctly into the correct formula. And then the second one will be for the answer 10 meters per second. You won't be penalized for the unit grade 12, but please ensure that the answer is up to the required standards. Okay. Moving on. We are still on literal equations. So the final speed of the printer, the final speed now is 15 meters per second. Okay, do you still remember that? Our V2 is 15 meters per second. They say express this number as a binary. We are now ignoring the unit. We take it as being just a number 15. So we need to change this into binary numbers. Do you still remember binary? Binary are the numbers that are used in electronics. That means in our electronic devices. And then the language that is used, or numbers that are used, there is only 1 and 0. So if you're given 15, that means 15 is a decimal number. So we need to change this into a binary number. That means you are writing this 15 in terms of 1 and 0. You know the method, grade 12. We are having different method of doing this. You can even use your calculator. You are more than welcome to do that. And then now, my method is I'm taking this 15 now, and then divide by 2, I will end up with a 7 with the remainder 1. Divide 7 by 2, I will end up with a 3, remainder 1. I divide 3 by 2, I will end up with a 1, remainder 1. And then now I am checking. Now, if you look at 1, 1 is not divisible by 2, all right? It will cause a fraction. And then now from here, now when I arrive at 1, I stop there, grade 12, with my division. And then I look at the answers that I'm having. If it's an odd number, we mean 1, 3, 5, 7, 9, 11, 13, 15, and so forth. Those are the odd numbers. If it's an odd number, it will take a 1 from binary. If your answer is 2 for even numbers, 2, 4, 6, 8, 10, it will take a binary 0. That is how we work with binaries versus the decimal numbers. So 15 is odd 1, 7 odd 1, 3 odd 1, and then 1 odd 1. And then now the representation of this number is from right to left. So that means it will be 1 from left, 1, 1, 1, and the base 2. So this 15 decimal is equal to 1, 1, 1, 1 in decimal form. So the answer will be for the binary ones, and then for the base 2 notation of that binary. So 1 mark for the answer and 1 mark for the correct notation. We are done with the equations, grade 12s, and then those are the basic equations that you may expect from your question paper tomorrow. And then we are still on algebra, 50 marks. We have nature of roots. And then with nature of roots, remember now in your quadratic formula, do you still remember that you have x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. So if you look at the nature of root works with a discriminant. And the discriminant is equals to b squared minus 4ac. But if you look at this part, this is exactly what is inside your quadratic formula square root sign there. So that means the nature of roots have a relationship with the quadratic formula. So now, what you need to do now before you answer your nature of roots, you analyze the question, read the question thoroughly. When you're analyzing, then you identify the following. To determine or to prove or show the nature of roots, you must start at this point. You start by saying discriminant is equal to b squared minus 4ac. If your question says determine the nature of roots or prove that the roots of these quadratic equations are as follows, then you will start with the discriminant equal to b squared. And then calculating the possible values of unknowns variable except x depending on the type of roots given. Then given that the roots are non-real, that means you'll be starting with the discriminant is less than. Okay. So now when you are analyzing, if it says calculate the possible values of the unknown, except you'll find that in your quadratic equation, you're having an equation that is saying let me use a different letter there, kx squared plus kx plus 2 may be equals to 0 like that. And then you must know that if they say solve for k, given that the roots are non-real, so you'll be starting by saying discriminant is less than 0, because you are given a condition that you are solving for k on condition that the roots are non-real. That is the difference between the two. The starting point is very important in nature of root grade 12. The minute the question says determine or prove or show, you start by saying discriminant is equals to. But if we are calculating another unknown except x in that equation, you start by considering the roots that are given to you and then now bring in your discriminant conditions. And then now check that the equation is in standard form before you solve. Remember, the same applies when we are doing quadratic formula. We started by checking that the equation is written in the standard form. And then identify the values of A, the value of B, the value of C from your equation there. And then note them down because you are going to need them. Your discriminant is having A, is having B, is having C there. Now, let's look at the question now. You are given m is equals to the square root of 25 minus 2x over x. They say determine the values of x for which m will be undefined. Can you see this is a fraction? When will a fraction be undefined, grade 12? You remember your conditions from grade 8 now? It's when your denominator is equals to a 0. Then this will be undefined. Why? Because in maths, division by 0 is not allowed. Okay, you can take any number into your calculator, 100 divided by 0. Your calculator will say error. Why? Because division by 0 in mathematics is not allowed. So it gives us an undefined solution. So for this equation to be undefined is only when x is equals to a 0. So that is the mark that we are looking for. And then now they say now we are given a condition for which m will be real. Determine the values of x for which this expression now will be the real one. Remember, we have two conditions of the real roots. Real roots when a discriminant is equal to 0 and when the discriminant is greater than 0. It's only then that you'll be having the real roots. And then now, what is our discriminant in this case now? Okay, before we go there, we can combine this and represent as one. So we'll be saying discriminant is greater and equal. Then it's catering for the greater than and the equal sign there. Now, and then if the discriminant is greater and equal to 0, what is the discriminant? Do you still remember I said to you, your quadratic formula is having relationship with the discriminant. Whatever is inside the square root sign, it's your discriminant. So we will start by saying discriminant will be greater and equal to 0. How do we know? Because the roots are real. And then what is our discriminant in this case? It is given as 25 minus 2x greater and equal to 0. And then determine the value or values of x. That means we are solving for x then. Minus 2x transpose 25 to the right. That is minus 25. Divide by negative 2 by negative 2. Do you still remember grade 12? I said to you earlier on, when you are dealing with inequalities, the minute you divide by a negative, you are affecting the inequality sign. So now minus 2 will cancel that one or goes once, then x will be, the inequality sign now will be less and equal to no more greater than. And then the negative divided by negative, it's a positive. So we end up with 25 over 2, or this 25 over 2 can be written in decimal form, of which is 12,5, or it can be written as 12.5. It depends on your grade 12. Whatever notation you prefer in that case is more than acceptable. Right, and then without solving the following equation, determine. Do you still, I've given you all the tips, grade 12. The minute the question says determine the nature of root, what did I say to you? You start at discriminant is equal to b squared minus 4ac. Okay, Brilliant. And then the first one is the a value there. And then coefficient of x is the value of b. And the constant is the value of c. We can just substitute that. B minus 6 squared minus 4ac, c is 1. Into your calculator straight to the answer. And then this is giving us a 12. Discriminant is equal to 12. So if you look at that discriminant, is it greater or less than? It is greater than 0 because it's positive. Is it a perfect square or not? It is not a perfect square. Perfect square are square numbers, grade 12. Perfect square is 1 because 1 squared is 1. Perfect square is 4 because 2 times 2 is 4. Perfect square is 9 because it is 3 times 3. Can you see 1 squared? 1. 2 squared? 4. 9, 16, 25, 36. Those are perfect square. That is why we are saying 12 is not a perfect square. And then now, if it is not a perfect square, what are the roots now? The roots are real, irrational because it's not a perfect square, and unequal. That is the nature of roots of that particular. And then in relation to your parabola, what do we mean about this? If the roots are irrational, that means now when you are calculating the x-intercept, you'll be forced to use a quadratic formula because you won't be having the factors. Okay, it's those quadratic equations without the factors. Okay, as you can see that if you look at this factors of 1 that can give minus 6, there's no way. It's only 1 and 1 for factors of 1. Okay, right, we move on. We are still on algebra. We have logs, exponents, and sets. But when you are solving logs, sets, and exponents, you are using laws. So you only follow those rules and laws to simplify expressions, or you will be solving equations using the rules or the laws of logarithms, sets, and exponents. Great church. You can't just answer the way you like. Right. Simplify the following without using a calculator. As you can see, this is the type of exponential type. And then now we need to write this as its prime base 81. Remember now, when we deal with the exponent, we will be using the prime bases. And then what are the prime numbers? When we talk prime numbers, they play a major role in exponents, grade 12. Prime numbers, we talk 2, we talk 3, we can't take 4, 5, yes, 6, no, 7, yes, 8, no, 9, no, 10, no, 11. That means it's a number that is divisible by itself and 1 only. We can't take 4 because 2 can go into 4. Can you see? 3 can go to 6 and 2 can go to 6. That is why 6 is not part of that. So that is how you select your prime numbers. So now when we solve exponent, we use this prime number, the basis then. So 81 is having a relationship with the 3. You can't write 81 in terms of base 2. So it is using base 3. So 81 can be noted as 3 to the power 4. And then we have our exponent minus 3 over 4 there. Then the 4 will cancel a 4 because they stay without using a calculator then. Then we end up with 3 to the power minus 3. That is 1 over 3 to the power 3. What is 3 to the power 3, grade 12? 27. So 1 over 27 is the answer for that. So the first mark is for writing this in 81 in exponential form. The second mark is either in exponential form or in a fraction form, second mark. And then the third mark is for the final answer there. We are still on exponents. We are having another expression. Simplify the following without the use of calculator again. And then now here we are having subtraction of exponent. As you can see, there's a minus there. And then now if you are subtracting or adding exponent, you must know that you need to apply the common factor method. Okay, for addition and subtraction of exponents. Do you see anything common there? Can you see? We already see 2 to the power x being common there. Automatically, there must be something in common. Or after writing your basis in prime basis, you will be able to see that. So on top, we are going to separate. We are going to take this 2 to the power x plus 1 to 2 to the power x multiplied by 2 to the power 1. Remember, multiplying the same base, you add the exponent. That is why we ended up with that. So we are reversing the process. And then this is minus 3. And then 2 to the power x and 2 to the power minus 1. On the denominator, we are writing that half with a base 2. That will be 2 to the power minus 1 minus x. On top, we are taking out the common 2x, 2 to the power x, 2 to the power x there. And then we will be left with 2 to the power 1 minus 3 times 2 to the power negative 1 is the same as half. And then on the denominator, it's a negative 1 times negative x, which is 2 to the power x then. And the 2 to the power x will cancel 2 to the power x. And then we end up with 2 minus 3 times half is 3 over 2. And then grade 12 is like we are subtracting the two fractions. Now we look for the LCM 2. And then 2 times 2 is 4. And then minus 3, the answer will be 1 over 2 there, without using a calculator. So the first mark goes to separating the exponents here on top and simplifying the denominator and write it as 2 to the power x. And the second mark goes to the common factor 2x there. The third mark goes to the bracket after taking out the common factor. And then now the fourth mark is for simplifying the LCM method. And then the final answer, half, that is worth 5 marks. Now we move, we are still on algebra, 50 marks, grade 12, logarithms. With logs, we also apply the rules. And then in this case, we are solving log x plus 2 base 4 minus log 3 base 4 is equals to 2. So now we are going to write the left-hand side as a single log of base 4. Correct? And then now the logs rules, it states that if we are subtracting the logs of the same base, so you need to divide x plus 2 divided by 3. So this will give us a 2 equals to 2. And then continue with the logs. Now you are changing the log notation to exponential form. So we will leave the fraction x plus 2 over 3. And then this 4 will move to the side to be a base. It will be 4 to the power 2, of which is 16. We are applying the logarithms laws versus the exponential rules, okay? Now we cross multiply because we are solving for x. We need this x here. 3 will multiply with 16. And then when you cross multiply that, we will be left with x plus 2 on the left-hand side. And the right-hand side will give us the 48. And therefore, x is equal to 48 minus 2, of which will be a 46. So the first mark goes for applying the log rules correctly there, where you end up with a fraction into a single log. The second one will be for the cross multiplication of 3 to the right-hand side there, and writing that 16 on the right-hand side, and the last mark will be for the answer. Hence, this is worth 3 marks. And then now we are still on algebra grade 12, our first 50 marks. We have complex numbers. Complex numbers is the notation, the rectangular notation, z is equals to a plus bi. Remember, this one is an imaginary number. The bi is our imaginary number. So under complex numbers, you will be expected to add, to subtract, to multiply, to divide. Complex numbers, to write a complex number in its conjugate. For example, if this is your original, the conjugate one will be a minus bi. The sign of the imaginary number is the one that is changing. To write this in rectangular form, okay, this number here, A, represent the real part, and then BI, the imaginary number. I've already explained that one. And then we have another notation of which is a triangular or polar form. And then now in a polar form, we have modulus of which is R and the argument of which is theta. This R is the same as the Pythagoras one. To calculate this, we use the same Pythagoras theorem. Okay. And then now to calculate theta, we use the inclination method, where theta will be tan off the given value there. So we'll see when you are doing the calculations on that one. So now this polar form, we have three notations. That is Z is equal to R sin theta. The second one is R cos into cos theta plus I sin theta. And then the last one is R, there must be a cap there, R cap theta there. So those are the three polar form notations. And then you must also be able to draw the Argand diagrams, and then also to calculate and draw the resultant forces of those Argand diagrams. Lastly, on complex numbers, you must be able to solve two unknowns on the identical complex equations. It's the same as the application of simultaneous. You are solving for two unknowns, but you are applying complex application on those identical complex equations. Right, under complex numbers, grade 12, we are given a complex z equal to minus 3 plus 6i over 3. And then they say write down the conjugate of this complex number. We are going to start in by simplifying this. It will be minus 3 over 3. We are separating this to its initial denominator. So now this rectangular will be minus 1 plus 3 into 6, which is 2i. That means this equation is basically representing that. And then now when you are looking at the conjugate, remember conjugate will affect the imaginary part only. So this will remain minus 1. This will change from minus to positive to negative, positive to negative 2i. So 2 marks is for the correct notation. That minus 1 is not affected, and then minus 2 has now taken a negative there. And then express z in a polar form. We are talking to the same z that you have simplified and ended up with minus 1 plus 2i. So we need to write this in a polar form, grade 12. In order to write this in a polar form, remember you need the value of the modulus r and the value of theta. Right, to find the modulus, remember modulus is using Pythagoras. It will be r equal to the square root of the a value, the b value there. That will be minus 1a value squared plus the b value squared, of which is 2 squared. So this is giving us how much, grade 12? The square root of 5. That is our r. You can even write in 2 comma something in decimal form, it's fine. And then now we need also to calculate the argument of which is your theta. And then now you must be careful when you calculate that theta. You can't just calculate before you know exactly in which quadrant is this line of the rectangular. So now let's check now. In which quadrant are we calculating? A is negative. Remember, this part is indicated on the x-axis, the b on the y-axis. And then now this is the imaginary part and the rectangular part there. So this will be rectangular, this will be imaginary. And then rectangular says minus 1, coordinating with a positive 2 on imaginary. That means now we are having an Argand diagram in quadrant 2. All right. And then after that, it's only then that you can identify the theta value, because it's from that side to here. We are talking this value here. Can you see grade 12? The value is between 90 and 180. So now we can now have our theta. And then this theta is in quadrant 2 is at 180 minus in terms of reduction. And then our arctan what? B over A, of which is 2 over 1. Or you can just write a 2. Remember this negative, it indicates the quadrant. You have already applied that one. So we end up with 116,54 as our theta value there. Relate this, check with the diagram. Is it possible to be the value of the theta there? Yes, because it is between 90 and 180 degrees. So now we are representing our Z in polar form. This will be Z. Remember, you start with the modulus, that means square root 5. And then C is what? 116,54 degrees. Or you can write the notation Z is equal to square root 5 bracket cos of 116,54 degrees plus I sine 116,54 degrees. The last notation, or you can give us as Z is the square root of that cap, square root of 5, and then theta 116,54. That is your argument and your modulus. And then this is the polar form. That is how you write it in a polar form. And then we have 6 marks for that. The first mark is for calculating the value of R substitution and finding the value. The third mark will be for the method there of finding theta and the value of theta. That is the fourth mark. The last 2 marks will be for the correct notation. It depends on you, grade 12, whether you use that one or this or that one. Any of the 3 is more than acceptable. And then still on complex numbers. And then we have x plus y. We now solve for both x and y if we are given that complex number. Remember, we are solving for 2 unknowns. These are the identical complex numbers. Why are they saying identical? Because we will be comparing to get the answers now. Right. And then x and y must be on the same side. And then all values without x on the other side. The arrangement must be of the same arrangement. Let's see, Rachel, what do I mean about that? On the left-hand side, we have x plus y. We leave them on the left because we need x and y to be on the left, the ones that we are calculating here. It can be any letter, grade 12. Okay. And then on the right-hand side, we are having bracket. That means we'll be applying distributive law of multiplication. 2 times 3, that is 6i. 2 times 2 plus 4. Minus I times 3 minus 3i squared. Minus I times 2 minus 2i. We are still simplifying the right-hand side. Do not transpose anything, grade 12, because your x and y is at the correct position. Okay. And then now we have 6i minus 2i, which is 4i, plus 4 minus 3 into I squared is minus 1. So x plus yi is equal to, this will give us a positive 3. It's a minus 3 times negative 1 plus 3 plus 4. That is 7 plus 4i. I am also rearranging according to this because they have started with x without I and then followed with yi. So it's the real value by a complex value. So now, as you can see that the value without I is x, therefore will be equal to the value without I on the right-hand side. Or the yi, can you see coefficient of I is 4 there? Coefficient of is y. Therefore, y will be equals to and 4. That is how you solve. That is how we say we are solving identical complex, because you compare the identical parts. So the first mark will be, let's look at the mark allocation, grade 12, is for multiplying the brackets out correctly. So the implementation of the -1 for I squared, and then the third mark is for the value of x, the fourth mark for the value of I. Hence, this is worth 4 marks. Right, and then now we have exhausted grade 12, our 50 marks. I hope we have all captured the 50 marks grade 12. And then second, we are looking at the 35 marks, of which is plus minus 3. This is on the functions. The prescribed functions is the straight line, quadratic, a hyperbole, exponential, a circle, and the semicircle. With the straight line, this is the original ymx plus c, or you can use y minus y1, mx minus 1. Quadratic is a to x plus p squared plus q, or the y equal to ax squared plus bx plus c. Hyperbola is y equal to a over x plus q. Look at that, it will all remain an x. Nothing will be added to that x grade 12. Exponential, y equal to the original a times b x squared plus q then. And then the circle is x squared plus y squared equal to r squared. That is for the full circle. And then for the semicircle, it depends on the graph. If it is a positive semi means half, it will be that side. If it's a -1, it will be noted below there, cutting at the negative. So these are the possible questions for the graphs. You must be able to sketch all the prescribed graphs, and then you must be able to determine the equation of the graph. You must be able to determine the equation of the asymptote on the hyperbola graph and exponential only. So the vertical hyperbola is having 2 vertical asymptote and the horizontal one, whereas exponential is having only the horizontal. And then you must be able to find the equation of the axis of symmetry in parabola and in hyperbola. In parabola is the same as the x turning point. So the equation of the axis of symmetry is the same as x turning point. That means grade 12, you can find that using x minus b over 2a. Okay. You must be able to find the domain and range for all your functions. You must be able to tell for which values of x is the graph increasing or decreasing. You must be able to calculate the coordinates of the point of intersection. That means the simultaneous equations where the two graphs will be equal. You must be able to interpret for which values of x is f at x positive or negative and so forth. Now, we are given the function f at x, x plus 1. Which graph is that grade 12? Is x to the power 1, therefore it's a straight line one. And then g at x equal to minus 4 over x. Which graph is that one? Grade 12 is the hyperbola one. You need to know your original equation. Sketch the graph of f and g on the same system of axes. Clearly show all the intercept with the axis and the asymptote. Let's start with f at x now. In order to sketch f at x function, you must be able to identify the shape. Remember, the shape of this graph is depending on the value of the coefficient of x there, that is your gradient. This is the positive gradient. Therefore, the graph will be increasing. And then we may look at the y-intercept when x is 0. So you let x be 0 there, y will be equal to 1. To calculate the x-intercept, you let y equal to 0. So if you let y equal to 0 here, you say 0 is equal to x plus 1. Therefore, x is equal to a -1. That will be our x-intercept, our y-intercept. We are done with the calculations that we need to sketch f at x. And then to sketch the g at x function, of which is the hyperbola graph, we need to identify the shape also. If you look at this, the a value, that means this value here, is less than 0, negative. So if that is the case, our graph will be in quadrant 2 and 4. And then now the y-intercept when x is 0 is undefined. Can you see that? When x is 0, we are not allowed to divide by 0. The y-intercept is undefined. And then you look at the x-intercept when y is 0. We put 0 there. And then on the right-hand side, you have minus 4 over x minus 3. We transpose 3 to this side. It's a positive 3. Minus 4 over x. We cross x to 3. That is 3x equal to minus 4. Divide by 3 both sides. X is minus 4 over 3. And then in decimal form, this will be minus 1,33. We must know exactly where does it lie, grade 12, that minus 4 over 3. We can now sketch the graphs, starting with the straight line 1. Y is equal to 1. And the x is equal to minus 1. And this will be cutting at those intercept, forming a straight line. Yes, it is increasing as we have predicted there. And then now to sketch the hyperbola graph, grade 12, we need to start with we have shape y-intercept. Oh, we forgot to put the asymptotes. Remember, it's a hyperbola, it's having asymptotes. So the asymptote, the first one is the free mark, grade 12, because all your hyperbolas will be having the asymptote at x equal to 0 for this one. And then for y, it will be y equal to, remember, y is taking the value here. That will be y equal to minus 3. That means 1, 2, 3. At minus 3, we are having an asymptote for a hyperbola. And then another asymptote will be on top of this y-axis here, because it's a line x equal to 0. And then now let's look at the x-intercept, because we do not have the y-intercept. Why? Because y-intercept, can you see the y line is the asymptote? That is why our graph is not cutting there. And then x will be at minus 1,33. Minus 1,33, we are taking a point there. And then now let's see grade 12 now. The first arm will be in this quadrant as per prediction of the shape there. So it will come closer to that without touching. And then the other arm will be a free arm on this quadrant here. Remember, you'll be given graph papers on your question paper at the back of your question paper, grade 12, ensure that you check there must be a diagram sheet for you so that you can sketch your graphs accurately, so according to the diagram sheet given to you. Right, and then now let's move to finance, growth, and decay. When we talk finance, we are talking investment, buying something on hire purchase, the inflation of the rate of money in our country, the inflation value, the tax value. We are talking the population increase or decrease in our country. That is what we are referring to when you talk to in relation to finance, growth, and decay. We will be bringing in the populations, the inflations, the higher purchase, buying, the investment of the money. And then now it's either it will be on simple interest, compound interest. And then now if you are on simple interest, that means high purchase falls under simple interest. Okay. So the high purchase falls under simple interest. The inflation and population, they are part of the compound interest. So now with the simple interest, if it is appreciating, the interest is added, increasing, therefore we are using a plus, and the n will be linear, and it's a equal to p into 1 plus in. If it's a decay now, that means the value is reducing. Like you are buying a phone now, in 2 years' time, the value of the phone will be depreciated. Then we use the a equal to p into 1 minus in. And then with the compound interest now, if the value is increasing interest or growth, you invest the money is growing at a certain rate, we use this as exponent n because it's compounded, right? And then when it's a decay, it is depreciating. Maybe you have bought a house now, in 10 years time, a house is appreciating is the first one. You buy a car now, and then in 5 years time, the value of the car will depreciate. Then you will be using a minus formula there. Okay, and then now we'll also have questions on nominal and effective rate. This is the formula you'll be using, grade 12. And then these formulas are available on your formula sheet at the back of your question paper, grade 12. Please make use of that question paper, the formula sheet, effectively so, and ensure that you copy your formulae correctly so. And then be able to calculate in all the formulas the value of A, G, I, N, because you can be asked to calculate any of the four. So the letter A stands for final amount after investment or the later value of your car. And then the P talks to the principal or initial amount or the initial price of the car when you buy it. And then the small I talks to the interest rate that will be added to your investment or added to the money that you borrow from the bank. And then N is the number of period that you will be paying in a money, maybe in a monthly basis for 5 years. It will be 12 times 5 and so forth. And then IE is the effective rate, IN is the nominal rate, M is the different period of compounding growth or the compound decay. Capital I is the interest charged on a loan or interest earned on an investment. For example, I invest the money now, 2,500. In 5 years' time, I receive 10,000. That means now they have added 7,500 into that money. That 7,500 is a capital I. But the small I, it is the interest they add every month. And if they say it will be added at 10%, that 10% is an interest rate. And then timeline calculations will also be brought in on your question paper. You'll be having one of that. And then what do we mean by that? There is more than one deposit or more than one withdrawal into your calculations. So money you'll be depositing, withdrawing money from the same calculation. Okay. Now let's take one example here. They say convert nominal. We are converting nominal rate 12.3% compounded quarterly to effective rate. Do you still remember now? We have just talked to the effective rate formula. It states that 1 plus I nominal over compounding minus 1. And then let's substitute y, I nominal 12.3%, and then compounded quarterly over 4 to the power 4, same value. Can you see grade 12 there? Minus 1. And then into your calculator, please take at least 5 digits after a comma, because this will be in decimal 0.12879, continuing like that. But this is not yet the answer, because now it must be the rate, it must be in a percentage. We are going to multiply this by 100 so that it can give us an effective rate of 12.88% to 2 decimal places. So first mark is for substitution into the correct formula. The second mark is for the decimal notation. And the third one is for the final answer in percentage. Remember to put in your percentage grade 12 after multiplying by 100. And then now our second activity on finance, growth and decay. We are talking to our 15 marks now. A high school proud learners bought machinery for 500,000. This is the name of the school a few years ago. And then it depreciates. To depreciate is now going down. The value is going down at a rate of 12% per annum on diminishing balance method. After how many years will the machinery be 150,000? Okay, grade 12, can you see now? This 5,000 is the initial value of the machine. The price of that machine was 500,000. And then the value depreciated to the machine, now it's worth 150,000. And then at the interest rate of 12%. After how many years? That means you are calculating the value of n. Can you see that? And then this is a depreciating formula. Therefore, is A equal to P into 1 minus I, because the value is depreciating. What is A? 150. 0. P is 500,000 into 1 plus rate 12%. And then we are looking for the value of n. Now, if it is depreciating, you must be careful. Your P must be more than A. If it is appreciating, going up, A must be bigger than P. Okay? Depreciating P will be bigger because the value is going down. But if it is appreciating from P, it will be increasing to A. So grade 12, do not confuse the two. And then from here now, we are going to divide both sides by 500,000 to remove this 500,000 from this side. And then we'll be left now with 150 over 500, of which is giving us 0.3. And then on the right-hand side, 1, this is the minus, not plus. 1 minus 12% is 0.88 to the power n. And then do not round off in between grade 12. Write whatever decimal, doesn't matter how big it is in between your calculation. You will only round off at the final answer. So we want n, and if you look at n is on the exponent, then we'll bring in the log. It's log of 0.3, this 0.88 will be our base there. And then now n. So this n is giving us approximately 9.42 years. And then this grade 12, is it 9 or 10 years grade 12? It will be 10 years, because if you say 9, you round off according to your mathematical knowledge, saying that 4 is less than 5. There's no way you can add 1. No, in financial math, we consider this as the real calculation now. If you owe somebody a money that you must pay back in 9.42 years, that means you are having full 9 years. And then 0.42 is the remaining month. You cannot say to me, you'll pay me within 9 years, because there will be still some money that you owe me for the remaining month. So to be safe, we are going to round off to the nearest, of which will be 10 years, so that we can cover the remaining part of the payment. So now this is worth 4 marks. The first mark will be substitution into the correct formula. Second mark for simplifying by dividing both sides. The third mark for bringing in logs. The fourth mark for finalizing your solution. Therefore, this problem is worth 4 marks. So that is your finance expectation grade 12. Please expect the compound simple interest and the timeline calculations. And then now we move on to differential calculus and integration, of which will be the last topics for us. Remember, we are talking to the last 15 marks now. Now, first question on first principle will be on first principle in your differential calculus. The first question on differential calculus will be first principle. Now we are using this derivative formula for first principle. They say determine f derivative of x using first principle. This is the formula. So now if you look at this, you need f at x plus h and f at x. F at x we do have, is what is given to us. So you need to find f at x plus h before you go to that formula. That simply means where you have x, we substitute x plus h, right? Minus x plus h minus 6. Simplify the bracket, minus x minus h minus 6. That is our f at x plus h. And then we take this formula now. We substitute in f derivative of x is equal to the limit of h approaching 0 of f at x plus h. What is f at x plus h? Minus x minus h minus 6 minus the f at x is 2 terms. We put the bracket. That is very important. Minus x minus 6, because this will be affected by this negative. That is why we are putting a bracket there. All over h, the limit of h approaching 0 is minus x minus h minus 6 as it is. So here we are going to remove the bracket. It's a negative times a negative is positive x. Negative times a negative is positive 6 all over h. The minute you have done this, grade 12, whatever is created here, it must be cancelled. If it doesn't cancel, that means you have made a mistake somewhere. 6 minus 6 plus x minus x, can you see, gives you a 0. So you are left with the limit of h approaching 0 of minus h over h. H over h is minus 1, then your answer will be minus 1. You continue writing limit of h, limit of h, limit of h. You only stop at the answer. It's where you don't put your lim anymore, because we are now at the final answer. We have already approached a 0 at the final solution. Now, the tip that I'm giving you, grade 12, the answer that you get there, it must be the coefficient of x there. Can you see it's minus 1? Then it is already giving you your final answer. So you just look at the value coefficient of x, and then you are projecting to get the same answer on your final after applying the first principle. So first mark will be for correct f at x plus h. Second mark will be for substitution into the correct formula. The third mark will be for simplifying. The last mark will be for your answer. So therefore, this is worth 4 marks. Sometimes examiners, they give 5 marks for that. They will also give a mark for h divided by h there. Right, and then now, after first principle, you will be having rules. That is the sequence of your question paper, grade 12. We are having rule number 1. It is f at x equal to a. A is a constant value there. Then the derivative will be 0. That means if I'm having the f at x of 2, that means if I'm deriving this, my answer will be 0. That is what this rule states. Rule number 2, f at x equal to ax, then the derivative will be a. It simply means if I'm having f at x equal to 2x, my derivative will be the coefficient of that x, of which is a 2. That is rule number 2. Rule number 3, f at x is equal to ax to the power n. Then my derivative will be, look at this, grade 12, this one we use it mostly in all, that means also in cubic function. When we are sketching, calculating the stationary points, we are using rule number 3. It says take the exponent and multiply by coefficient. That is why we have n times a there. And then from the exponent, subtract 1. That is why we have n minus 1 there. That is the application of this whole derivative there. Let's take an example now. Let's say I'm having f at x equal to 5x to the power 2. It means when I'm deriving this, now I will take exponent 2 times 5, it will be 10. And then I will subtract 1 from the exponent. It will be 2 minus 1, therefore I will be left with 10x to the power of 1. And then here we also check notations. If we are given your formula in terms of x, when you derive, you put this dash here to show that you are deriving. When you are given in terms of y equals 2, you say dy dx when you start deriving. When it is given as dx, you only give us the solution. We don't want to see that dx on your derivative. And also when you have d over dy as your equation, you only want to see the answer, nothing else. You will be penalized for the incorrect notation. Before you derive, simplify brackets and fractions as far as possible. Write that in exponential form. Remove variables on the denominator, grade 12. And then let's look at the rules of differentiation now. Determine f derivative, as you can see, of this equation that is given there. There is a lot that you need to take care of before you derive. You leave f at x, You write this, remove the third because you don't need those thirds. It will be x to the power 3. Then these two will become a fraction there. And then this one, we leave it as it is. Happy now, they've written already like that. This one is half. We take this x to the top. No variables on the denominator. It will be x to the power minus 1. At this stage now, happy we can now start deriving grade 12. Look at my notation. I am putting a dash there to say to you I am deriving. And then the rule says coefficient multiply by 1, 3 over 2x. Subtract a 1 there, the answer will be 1 over 2 and the exponent. Minus 2 times 2 minus 4x. Subtract a 1 minus 3. And then from this one, remember this x is down there. Minus 1 is the one that is the exponent. Minus 1 times minus half, positive half. And then x minus 1 on the exponent will be minus 2. So now it's 1 mark for writing this, removing the third. And then second mark for this derivative, third mark, another derivative, the fourth mark for that derivative. Hence, we have 4 marks then. And then now grade 12, another type of the rules differentiation. We cannot derive with a variable in the denominator. We need to get rid of this x here. How are we going to do that? Because we are busy simplifying, we keep this notation d dx. We want to deal with the bracket. Now we are going to divide this x into each term there. So 2x squared divided by x is 2x. Plus 3x divided by x is 3. Minus 1 divided by x is minus 1 over x, of which we take this x up, it will be minus 1x to the power minus 1. So it's the same as minus x to the power minus 1. And then now we can now derive, because everything is linear. The minute we derive, this disappears, grade 12. We give us only the solution. We said rule number 2, if it's 2x, the answer is coefficient of x, okay? If it's a constant, the answer is 0. And then lastly, the third rule, it says minus 1 times minus 1 is a positive 1. And then it's x to the power minus 1 on the exponent minus 2. So it's 1 mark for simplifying second derivative, first derivative, and followed by another derivative there. So this is 3 marks. And then the average gradient of f at x equal to x squared minus 1 between the points where x is 2 and x is equal to 2. Average gradient is still a gradient. It's the change in y over the change in x. That means y2 minus y1 over x2 minus x1. So in this case, we only have the x value 2. We need y value for that. We have the x value 6. We need the y value for that grade 12. That is our starting point. So we are going to look at f at 2 with this equation here. That will be 2 squared minus 1. And then that is 4 minus 1, of which is 3. So 2 goes with the 3 there. And then f at 6 will be 6 squared minus 1. That is 35. 6 squared is 36. Minus 1 is 35. So 6 will coordinate with 35. Then this will be our x1 and y1 and the x2 and the y2. So we calculate the average gradient by using y2 minus y1 over x2 minus x1. Same method, we are talking to gradient. y2 35, y1 3, x2 6, x1 2. 35 minus 3 is 32, 6 minus 2 is 4. 32 divided by 4, the answer is equal to 4, 8, 12, 16, that is 8. Then that is the average gradient. So that is how you calculate it. Gradient is a gradient. Doesn't matter it's on the straight line or where, but you need 2 points on that. Determine the equation of a tangent to the curve defined by this. At a point x equal to 1. Now you look at this, there's a parabola, positive parabola, and then at x equal to 1, there's a tangent touching at a point of contact where x is equal to 1. As you can see, we don't know the y value there. So that's your starting point. You start by calculating the y value for that, where x is 1, using this equation. Now, that will be 5 into 1 squared minus 3 into 1. And then this is giving us 5 minus 3, of which is the 2. So this one coordinate with the 2 then. After finding the coordinate now, you need a gradient, because if you look at the equation of a tangent is a straight line. That means you need a gradient and a point to find its equation. So now let's look at the gradient. To find a gradient, you are depending on the derivative of this function. Derive this, that is 2 times 5, 10x, subtract 1, we are left with 1 there. And then this one, you take coefficient, is rule number 2 minus 3. It is tangent to this at what point? 1 and 2. So you take x1, g derivative at 1, 10 into 1 minus 3. So our gradient for the tangent will be 10 minus 3, of which is 7. Now we have a gradient, we have a point. You can find the equation mx plus c of that straight line tangent. Our x and y is 2, the gradient is 7, x is 1 plus c. The aim is to find the value of c. That is 2 equal to 7 times 1 is 7 plus c. Therefore, c is 2 minus 7 when you transpose this, which is minus 5. Therefore, the equation of this line is y equal to 7x. We are substituting in there the value of m and c only. 7x minus 5. That is the equation of that tangent. The first mark goes for finding the correct point, coordinate 1 and 2. The second mark for the correct derivative. The third mark for the value of the gradient. The fourth mark for substituting the gradient and a point on the straight line. The last mark for the correct equation there. Then that is your 5 marks, grade 12. Okay, and then lastly, we are looking at the cubic function. That the cubic function is the function of x to the power 3. And then now they say determine the y-intercept. You know, in all functions, to find the y-intercept, you let x equal to 0 there. Okay, and then when x is 0, 0, 0, 0, therefore y is equals to 8. Done. Great jobs. Okay, and then now the third one, determine the x-intercept. To find the x-intercept, you let y equal to 0 then. Then you are left with x cubed minus 2x squared minus 4x plus 8. And then you need to check the factor now. Substitute a 0, substitute a 1 minus 1, looking for the one that will give you a 0. 2 minus 2, 3 minus 3, and so forth. As I was testing grade 12, I found out that x minus 2 is the factor of this. That is the rule that you also need to check. And then now, after that, this will assist you to find a trinomial. It will be x cubed divided by x, that will be x squared, and the last term, 8 divided by minus 2, that is the minus 4. So you are left with only the middle term there. You can use any method. Others are using synthetic division. Others, they use a long division method. I prefer this short method there. And then now we need this b only. So we are going to do this grade 12 also. That is the method we are using. And then at your site there on your scrapbook, or no scrapbook, sorry, you'll be using the exam book. So you can draw a line and do your rough work on the right hand side of your book, and then with your pencil, and then on the left hand side, give us the real solution. Please cancel after the rough work so that we can know exactly which one is the correct answer. So if we multiply these two, they give us bx squared, and then these two, they give us the minus 2x squared. So minus 2x squared plus bx squared is equal to the x squared on your expression there. That is minus 2x squared. So bx squared, when you transpose this to the side, it will be positive. It is giving us the 0x squared. Can you see the b is equal to 0? That means we do not have a factor there. So a value there, it will be factor x minus 2 into factor x squared minus 4, because the b is the 0 from the calculation there. So the final factors will be x minus 2. If you factorize this difference of two squares, it will be x minus 2 and the x plus a 2 there. So we end up with x equal to 2. For these two is the same thing, or x is equal to a minus 2. So those are the x-intercept of that particular function. Hence, it is 3 marks. It is 1 mark for that vector, 1 mark for these vectors, and the final x-intercept there. Determine the coordinates of the turning point. Remember, turning point, we are talking stationary. We look at the derivative of this. Can you see derivative is playing major role? 3 times 1, 3x minus 1, 2. 2 times minus 2 minus 4x to the power 1. Rule number 2, you take coefficient. Rule number 1, this becomes the 0, the constant value. And then you let this equal to 0. And then from there, you factorize. And then this is giving us 3x minus 2 and the x minus 2 as being the correct vector. So x is equal to 2 over 3 for the first bracket there, or x is equals to 2. Then grade 12, you take this x and substitute into original equation to get the y value. Where you have an x, you put in 3 over 2. Then this will give us the y, that is 9,48. And then for the x equal to 2, it will give us a y that is equals to 0 there. So if we write this in coordinate form, 2 over 3 is the same as 0,67, coordinating with 9,48, and then this one is 2 and 0 there. So now when you are comparing to your graph, you need to identify which one is the biggest value between the y values here. You can see 9. That means it will be the maximum turning point. This one will be the minimum because 0 is less than 9,48. You can even predict from that point, grade 12, how is your graph going to look like in terms of maximum and minimum values. And then now sketch the graph, show all the intercept. We are using all the calculations that we have calculated above, grade 12. So remember, we have x-intercept minus 2 and 2 from the previous calculations. And then we have y-intercept equal to 8, positive 8. We have the turning point at minus 2 over 3, coordinating with a 9,48 there. And then we have 2 and 0 there. Then this graph will go this way, turning there and going up there. So that is the graph we are expecting. 1 mark for the stationary point, 2nd mark for the x-intercept, x and y, and for the shape of the graph there. So now, lastly, the last topic is on integration. Integration, you use these formulas, grade 12. They are at the back of your question paper. Look how do you relate that. When we are talking, okay, let me have 4 multiply is 4 multiplied by 1 over x. Remember, this is 1 over x, okay? It's the same as this integration. Already I can see the relationship. And then minus, or let's leave the integral sign there. Minus 3 to the power 2x. 3 to the power 2x is this type. 3 to the power 2x is that type. And then now, this notation is fine. And then the last one, minus 2 is the same as 2x to the power 0. That means it is this type. Can you see? The answers are already there for you. And then this is the dx. So now let's start deriving. We are deriving 1 over x. It says it must be in the ln of x. Okay, and then now we move to the second one, 3 to the power 2. We are looking at that one. Okay, it says take the constant value 3, and then now you have exponent 3 to the power we have 3 to the power 2x on top. Okay, or is this one, colleagues? Is this one, grade 12? So you take 3 to the power 2, and then on the denominator is the ln of a. What is your a in this case? Is 3, correct? And then this one is rule number 1. That is 2x to the power 0. It will be plus 1 plus 1. Can you see that? So it will be 2 to the power x. 2x to the power 1 over 1 is still the same. Then this will take a plus 3 after integrating. And then we bring in the 4 now. In each term, it will be 4 ln of x minus 4 times the 3 to the power 2x over ln of 3. That is 2 ln of 3 there. That means it's 2 ln 3 minus 2x plus c. And then we simplify this one, 2 into 4, 2 times. Final solution is 4 ln x minus 2 multiplied by 3 to the power 2x over ln 3 plus 2x plus c. So the first mark, grade 12, will be for writing this into the correct notation there. Second mark, third mark, and the fourth mark. I think this must worth 4 marks, not a 3 there. Okay. And then now the next derivative, 19.2, we are still integrating. So you cannot integrate with the 2 brackets there. You need to simplify those brackets first. That will be 1 minus 4x plus 4x squared dx. And then let's integrate now. Remember, this one is 1x to the power 0, right? Then it will be x to the power 1 because it's a plus 1 plus 1. Minus 4x squared over 2. Plus 4 is rule number 1 throughout grade 12. 4x to the power 3 over 3 plus c. And then this is x simplified to x squared plus 4 over 3. And then the x cubed. So first mark is 4. A bracket there, second mark, the third and the fourth mark. So this is worth 4 marks. And then lastly, our last question on your question paper will be on the area below the curve. This is your question paper, grade 12. Last question, format of your question paper. The area below the curve. That is the application of the definite integral. This one is a definite integral. It's not the indefinite one. It is definitely a definite answer. So they say the curve function f at x equal to minus x squared plus 3 is drawn. Determine the area of the shaded bounded by the curve and the x-axis between x equal to minus 1 and the x equal to 1. The first thing that you do, you give this notation in integral form. The maximum value, minimum value from the x values there. And then now you put in your integral, of which is this formula here, minus x squared plus 3 dx. That is the first mark. The second mark is for giving us the derivative of this bracket here. And not the derivative, the integral of this bracket. That will be minus x cubed over 3. Okay. Remember, this is x to the power 0. It will be plus 3x to the power 1. And then you make a square bracket. They indicate the minimum and the maximum value there. Maximum and minimum. And then the next step, you are now substituting. Minus, can you see grade 12? I'm starting with my bracket. This is assisting me to avoid confusion. I know I will be substituting the x's only. Then I leave a space for x there over 3 plus 3 and then space for x. This will assist you, grade 12, to have same brackets, same thing inside your bracket there before you substitute. Because some learners, they have different things inside the bracket. They are supposed to be exactly the same. So first bracket, you substitute the maximum value. And then the second bracket, the minimum value there. And then you can put everything into your calculator, grade 12. This is giving you the answer of 16 over 3 square unit, of which you can write it as 5 1/3, or you can write it as 5,33. It's up to you, grade 12, of which is the unit squared. So grade 12, this brings us to the end of today's lesson, and then good luck with your exams as you will be sitting for your paper 1 as of tomorrow. And then this lesson was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. All the best, great jobs.